Good morning, everyone. Thanks for being here. So, what I would like to show you is our experience when Wildfire was acquired by Google, and we had to migrate. We wanted to migrate our platform from Amazon and AWS to Google Compute Engine, and I'll try to show you some challenges that we faced, some problems, and some mistakes that we did. And what I would like to do is to give you some food for thought. So I won't go very deeply into technical details. If you have any question later about Google Compute Engine, feel free to reach me. But I'll try to keep the presentation a bit on the high level, because I want to give you some hints on how to manage a process. So the whole process took several months and for a team, and we did a lot of things. So I will show you a bit what is Wildfire, what was the platform I want to migrate, and how we did it, how we managed the process, and all the things that we did. So about Wildfire. Wildfire was a startup, mostly based in California, with an office here in London. When I worked at the time, it was acquired by Google in 2012. It was mostly a Ruby on Rails shop, so it was a typical setup for a startup back then. I'm not sure if it is anymore. Maybe Ruby on Rails is not so popular, but I guess it was the standard setup for a startup, and I think there are a lot of startups right now in the same situation, and working with Amazon AWS, Amazon Web Services. The team I was working was the ops team. I was in charge of the London part. The team was distributed around the world, actually. It was mostly a remote team, and we managed the infrastructure mostly using Chef as an automation tool. I'm mentioning Chef here, and there will be during the presentation some Chef terminology, but I will try to keep the presentation as much as I can technology agnostic, because I don't want to be a presentation about Chef. So if you are not familiar with Chef, it doesn't matter, don't worry. The process is the same if you are working, for example, with Puppet or Ansible, or even more complicated system like Mesos or Kubernetes, or maybe you are using Docker right now. And if you don't, you should. As I said, this is what we try to do. We try to migrate the platform was running on Amazon AWS to Google Compute Engine. Just a bit about Wildfire. Wildfire is a company on the social media marketing. There was a lot of hype in 2012 about social media marketing. A lot of companies got acquired by big names, and so we were acquired by Google. We provided a set of applications, as I said, mostly on Ruby on Rails. The main goal of the set of application is engaging users on social network. Our customers were top brands, so we had at the time the top. We had about 30 of the top 50 brands, global brands in the world as a customers, and whenever one of those brands wants to engage with its user base on a social network, maybe running a contest or a sweepstakes or something like that, we provided the set of applications. We had also a couple of applications for the analytic parts. So how many of your customers or user base is liking a post or are actually engaging with one of your posts or one of your tweet or one of your Google Plus post and something like that. And it is a complex set of applications because we had about 10 different applications running on production, and almost every application has a customer-facing site, so a standard web application, and has an internal API because each application needs to talk with the others. So we provided a set of REST API. What about the stack, the technology stack? So, as I said, we were a typical startup at the time, so we used Ruby on Rails, Nginx as a front end, and a bit of HA proxy. On the back end, we used Unicorn as an application server. If you're not familiar, it's just a server that provides your web application. It runs the Ruby on Rails app. The usual MySQL and a bit of other technology for databases. So just to keep things complicated, one of the team decided that they wanted to use Cassandra. I didn't mention that each application has a different development team. So we had separated teams for every app. So one team decided that they want to go with Cassandra. So another application is running MongoDB and something like that. About the infrastructure, again, this is I think a very typical situation even right now. Hundreds of virtual instances running on the Amazon Web Service using Ubuntu. At the time, we were using Ubuntu 12.04. We had one instance, or better, every instance was dedicated to a specific role. So we had instances for front-end, for backends, and for DB, for workers, for messaging, and something like that. We used S3 for saving some assets. S3 is a technology provided by Amazon. We use the ELB, which is simply the load balancing technology provided by Amazon at the time. And we had multiple environments. Again, I think very typical setup. So we had a development environment, actually multiple ones. We had a testing environment. We had a production environment, something like that. At the time we were acquired, Wi-Fi was already running for, I guess, a couple of even more years. So what I would like to tell you about the production environment is that when you have a production environment that has been running for a bit, you have a team that is responsible for it, and maybe it's not even the same team that started the production environment. So you have usual turnover. Some people are not working anymore on the team, so you don't know all the infrastructure very well, because maybe you know very well some part of the infrastructure, you know very well MySQL, you don't know very well Cassandra, and maybe the guy who knows very well Cassandra is not working anymore with you, and something like that. So Um, if you have a production environment, it is a legacy environment. And in the meaning that when you have an environment that has been running for a bit, of course, you don't have the whole picture. So you need to treat your production environment as a legacy environment. It's not in a bad way. It's not a bad word. Maybe you associate a bad meaning to the legacy, but you need to do some things and treat your production environment as a legacy environment, because you cannot change everything, for example, or something like that. And so maybe this is one of the first advice. Remember that your production environment is actually a legacy environment. About the tools I mentioned before, Chef, use Chef for orchestration. If you don't know, Chef is a tool for managing installation and actually doing some ops on a bunch of instances. The same for Puppet, the same for Ansible, for example. It's now very popular. We kept away from the command line, so we didn't do anything manually. And we had one big Git repository for our code base. So our infrastructure was actually a code base. Everybody is saying infrastructure as a code, or was saying at the time. So this is another important thing. Actually, the infrastructure is a code base, it's code for us. And we treated the migration as a software porting problem. So there was an abstraction. We didn't think about the infrastructure or the platform per se, but we thought about the migration as a software problem. So we are trying to port our code base from a technology to another technology. This is a Chef terminology. Cookbooks are simply a collection of scripts. It's not, if you know Chef, it's not a very precise definition, but just for the sake of the argument, think as a set of Ruby scripts that they are running, they are doing any kind of system administration on your platform. We use a bunch of side cookbooks and community cookbooks. It means that we had a lot of custom written code during the year, and as I said, written maybe by people that it's not working with you anymore. So you cannot ask whoever wrote the code why the code is doing that or this and something like that. And we used a bunch of scripts provided by the community. There is a huge community for Chef or other tools where you'll find some already made scripts for your task. And just mentioned, we use a tool for managing this mix of cookbooks, this mix of scripts, which is called Librarian Chef. We had roles, again, a Chef terminology, but it's also common sense meaning. So each instance has a role. So we had the front-end role, the back-end role, and something like that. A role is just a collection of scripts, and what is called in Chef metadata, just some data that needs to be applied to that role. So this is an example of a role. This is the front-end role, is JSON. As you can see, there is a list of what is called recipes. Again, a list of scripts that apply to kind of role, and a list of data. This is in particular data I use for monitoring because we use the Sensu as a monitoring tool. About the process, why we did it? Of course, we were inside Google. We want to manage to leverage the Google infrastructure, to reduce the cost, to improve the efficiency, but also we need to do the transition without any customer impact. So in the ideal way, we would like to do the transition without downtime, or minimizing the downtime, of course. So as I said, we treated our migration as a software problem. And first thing, you create a whole, or you fork your old code base for the new project. And this is where we learn the first lesson, that preserving the history is really, really important. Because otherwise you have a whole script that has been created by the same guy at the same time. You don't know anymore why or when this line was written and by who was written. So Git brain doesn't work anymore. So lesson one, preserve the history. Even if you are creating a new project and you are working with a totally new platform, preserve the history of the old one. Porting. So we had a porting problem, and we said, okay, we need to analyze our code base. The first step in any porting project is analyzing your existing code base. So we need to check what part of our code base is using or is referencing directly some Amazon features. And here we learn our second lesson. Your code base is very complicated also because it's think about a collection of scripts that they are doing very different tasks. So you have scripts for installing packages and scripts for deploying application, something like that. So you need to learn your dependency graph because your code is including other code, and it's more complicated than you think probably, because you discover that your part of code that is including or that maybe is installing a package depends on a part of code that is doing a totally different lesson two, analyzing the dependency of your code base. So which scripts include other scripts, and maybe they include other scripts, and so on. And then, yeah, GraphViz here is your friend. I will show the next slide. There is the result of this analysis. And then, while doing this dependency task, we learn the lesson 3. Know where your scripts are used. It seems trivial. It is not. You need to know that maybe one script that you think it's really important is actually running on a couple of instances, and then another script that you think it's not important is running on 90% of your instances, something like that. So this is also very important. Map your code base to your infrastructure. So as I said, what machines, what instances are using your script, and how many instances are using that part of code, and something like that. This is an example of, this is actually our code base, our dependency. Each node is a cookbook in a chef or a script, and an arrow means that there is a dependency. The script is including other scripts. So there are a bunch of scripts that they have no dependency, and so you may think that it's easy to port. And there are a bunch of scripts that are included everywhere. So we finished the analyzing part, and we said, okay, let's classify the effort that we need to do the porting. So why not use some use 3 buckets: easy, medium, and hard effort. So we said, okay, we define the easy part, the set of scripts that they don't depend on any kind of feature of the platform. They are platform independent. So they don't use, for example, any API, and they can be ported with very low effort. The medium effort for the porting. So cookbooks that, again, they don't depend on the platform, but maybe they require some slight change because the DNS or the internal networking is different. So, for example, there are some changes in the names or the network names or something like that. This is a real example. Maybe you are using the interface 1 in your platform, and you discover that in your platform the interface is called in a different way. And then the really hard part, which is the set of scripts that they are actually using the platform. So they are calling the platform API. The typical example is scripts that they are used to create disks, managing instances, creating snapshots for disk, any kind of script that is used to manage resources, physical resources for your platform. This is an example of the code. And then we learned our lesson 4, that this classification doesn't really work, because doing this analysis, we learned that there are some other levels of classification. We learned that there are some scripts that are totally obsolete, that you don't need to be ported. So you can actually delete the whole set of scripts. And that's my favorite part. And then you have, again, easy scripts imported. And then you have some set of custom. This is quite important. You have a set of custom scripts written during the years, and then you discover that there is a community solution which is much more elegant and which is more powerful and something like that. So maybe you think, why I don't totally remove this custom written code and I use the community solution. And then again, the medium and the hard effort scripts. And then you have some scripts that you need to rewrite from scratch. So what we did, we started with removing the custom written code where possible. When we found a better solution in time. Of course, you don't want to change custom written code for some code that you find and then you discover that it's not maintained, so you just swap a problem with another. And swapping the code, even if the functionality is the same, maybe you need to change something in the script that they include your changed script. So you may discover that some scripts that were easy to be ported, now they are less easy, or the contrary. And then you go back do the classification task. So you try to put your code base in a bucket. This is easy. This is obsolete. This needs to be rewritten and something like that. And this is one of the most important lessons we learned. Never choose the path of the least resistance, because you are tempted to do maybe the less amount of work as possible, and that's wrong, because you will simply port in your porting effort. You will port your bugs on the new platform. You have some bugs or technical debts, and you simply port them on the new platform, and you will have the same technical debts. So don't be afraid to, for example, write something from scratch. Don't be tempted. Sometimes a lot of us, they are tempted to rewrite everything. Of course, this is also wrong. Don't be afraid to use other tools. I mentioned it before, the Ibrahim Chef, just because we discovered that it was better to use Bash Chef. I think now anyone is using Bash Chef. At the time it was. Yeah, so the most important thing, use the process of the porting of your creating your platform as a chance to solve your technical debts. Don't be afraid also to write tool, and try to write tools for every single task. Even if it's a simple task, it's a very simple task, and you say, okay, I'm creating a new platform, I'm doing this for only one time ever. I will never need to do this single task anymore, so I can do manually instead of spending a couple of days writing a tool. And then you discover that when you have your whole new platform, you need to destroy it because there is an error, or you need to do something different, and then you need to destroy the whole new platform, recreate from scratch, and the simple task that you did, you have to do again manually. And at the third time, you say, okay, maybe I should have written a script, an automated tool. And we did this a lot of time. We created the platform and destroyed and recreated so many times. And then another thing that you should try to do is use abstraction. Try to isolate in your code base the feature that they are using your platform API, for example, and try to put on if possible, on a single part of your code base. If not possible, minimize the numbers where this happens. And so, for example, in the cookbooks, in the chef community, there is a single cookbook that use all the Amazon or Google Compute Engine API calls. The abstraction means that you can change the platform easily, not so much, but don't rely on simple features that they are used on only one platform, if possible. So try to keep things simple, but again, remember to avoid the path of least resistance. Another important thing is that your production platform, the old one, is still running, is alive. Part of your team is dedicated to keep it up and maybe scaling and maybe doing some changes. And you will find that you need to port some changes from the platform, from the old one to the new one. Or, on the contrary, while you are working on the new platform, you solve a technical debt, or you solve a bug, and you say, why I cannot backport this fix on the old platform? So there will be a lot of exchanges between the code base. And you need to track the differences. you need to know the differences between the two code bases. And don't be tempted to keep things equal. So there is no way that you will have the same things at the end. The two code bases will diverge at some times. And it will happen anyway. And then you have, of course, you set up the new platform, you finish your porting project, you up your new platform, use this part of the process as a way to do architectural changes. You won't have any other change. Once the platform is on production, doing some architectural changes, it's very difficult. So use that part to experiment with new architecture. Don't be afraid. Deploy the apps. That will require a whole new torque. If you use maybe a continuous development, continuous deployment environment, or whoever is deploying the apps, you need to be transparent. You should be able to deploy the apps on both platforms in the same way. So it was a very high level. There were not many technical details. What I would like for you to remember is avoid the path of least resistance during the project. Solve technical debt. Use the chance to solve technical debt. Treat the migration as a software porting problem. There will be some differences between your two code bases. It's impossible to avoid them. And I think that's all. Okay. Thank you. Yes. Any questions?
Any questions?
In one of your slides, you mentioned about the rationale to move to Google Compute Engine, and you had three things, and one of those was to improve the efficiency.
Yeah.
Right. So my question is like, what things you considered, you thought that you gained efficiency after moving to GCE, and did you gain those efficiencies, or did you get, or what you gained that you didn't expect?
So in this case, efficiency in our phase, we discovered that we.
Marco, sorry, do you want to repeat the question?
Yeah, so the question was about the rationale of the migration. I mentioned the efficiency. Did we actually gain some efficiency? So efficiency in our case, what I think that the most important gain was that we were able to use less instances. So the power of the platform was gained with a number of instances that was less than the previous one. So that was in our case the efficiency. We were able to reduce the number of instances, or using the same number, have a more generate more traffic and have a more scalable solution. It was very briefly our efficiency gain.
Next question. Should work now.
Yeah. So what are the main differences between GCE and AWS that cause the most problems? How do you hope that GCE would have made your life easier in migrating?
So what we call it's because the most problems was that was not the API. There are of course differences in the API or the way you call the API, but it was a funny thing because Amazon used a different naming scheme for resources. they have quite a unique name. For example, instances and they are called I dash and then number, and a disk is always V and a number for volume, while GC uses a slightly different naming scheme, so they have a unique resource, but you cannot tell actually directly from the name if it's an instance or a disk or something like that. So that's what caused the most problem from us, the differences in the naming. But it was a small thing. It was just a strange thing that we discovered in the process. So,
So obviously when you're moving to inside Google, you have access to various, what would be previously AWS instance, but instead to be deployed using service providers such as Google products in general. Did you find yourself with higher number of instances or did you duplicate them inside the Google Cloud?
sorry, can you repeat the last part of the question? Did you?
So things like load balancers and database servers, I envisage that internally in Google, you can access them as sort of more general Google Web Services rather than instances. Do you find yourself migrating towards shared Google infrastructure or reduplicating your existing AWS infrastructure but inside Google managed virtual machines?
So the Google Compute Engine is I would say a totally separate part from the Google internal infrastructure. So we migrated from a cloud infrastructure like Amazon to another cloud infrastructure. In this part of the project, we didn't use any kind of internal Google resource actually. So we didn't use any Google web server or load balancer, something like that. So we use the same cloud technology that is available to everybody outside in the world.
Any other questions? We have time for, I guess, last one question. No?
So you mentioned that you managed you gained efficiency improvements in your migrations, and at the beginning of your talk you mentioned how you recommended Docker. So Docker, is that correct?
We weren't used Docker at the time, yeah. So mostly because our platform, as I said, was a legacy platform. So when it was started, Wi-Fi Docker technology wasn't available. So.
Did you go from a virtualized instances to contained services?
Yeah. Yes, that's a good question. It wasn't part of the talk, but as I said, we tried to use the migration to do some architectural changes. And so actually, yes, we tried to change the way we deploy the application because in the old platform, developers were responsible for deploying the application in a very complicated setup using, if you are familiar with Ruby on Rails, we use a lot of custom Capistrano rules. But yeah, we moved actually to a Docker deployment, let's say, in the second part.
Anyone else? We still have 1 minute, so one more question, you can fit in.
Thank you.
No, we have one question.
Oh,
So every time I myself or anyone I know has to choose a cloud platform to start a project, most of the time they end up choosing us because it's cheaper. That's the main argument I hear around.
Yeah.
Would you say that it's justified that Google Cloud Engine is more expensive, or is it actually not more expensive? Why would you choose EC if you don't have it for free as you had?
Well, that's a good question. I don't think I can answer that because I don't know very well if it's more expensive or it's less expensive. That goes back to the part of efficiency. We discovered that we could use more power with a less number of instances, but I cannot really tell about the cost or doing some comparison about cost. Also because, let me say in general, this is a very competitive market, so the cost that, even if I look at the cost we were looking during the migration project, that was a month ago, I'm sure that the costs right now are totally different because they are going down. So I'm sorry, but I cannot really tell.
I actually have a last question. So, you mentioned about using Unicorn.
Yes.
How was your experience using that Unicorn in actual production environment?
Yeah, that's a good question. It was a mixed experience. It worked very well in some part. It didn't work very well in other parts. So maybe we can talk if anyone is interested. But yeah, we have some problem in scaling Unicorn on some specific issues.
Okay. All right. So I guess we wrap up. You're gonna give few giveaways for the best questions that you like.
Ooh. So I'll give you one, not for the cost, but for the previous question. And I'll give you one for the efficiency question.
So clap everyone, please.